Now look at part B of question number 6. Write the value function, find del y star by del P1, del y star by del P2, and del y star by del L naught using the envelope theorem. Okay. So we again set the Lagrange, but this time it is given that P1 and P2 and L naught are variables. So I will not use the value of L naught equals to 1000. I will not use the value of P1 and 1 and P2 as 2. We will take them as variables. Okay. So what happens now? My task becomes maximize P1 Y1. So P1 100 root L1 plus P2 Y2. P2 50 root L2 subject to L1 plus L2 is equal to L0. So now we have to set up the Lagrange. So what is the Lagrange? The Lagrange is L, L1, L2. Okay. And L0 is also a variable now. So, and lambda will be my greater than or equal to 0. The constraint, what do I say, constant. Okay. So I have 100 P1 root L1 plus 50 P2 root L2 minus lambda L1 plus L2 minus L0. Okay. So now for maxima and minima, del L by del L1 by this should be equal to 0. So this implies that 100 P1 divided by 2 root L1 minus lambda into 1 equals to 0. This implies that lambda is equal to 50 P1 by root L1. Now del L by del L2 is equal to 0. Del means partial derivative. So 50 P2 divided by 2 root L2 minus lambda into 1 is equal to 0. This implies lambda is equal to 50, so 25 because I'll cancel 2. So 25 P2 divided by root L2. From these two equations, I'll get 50 P1 divided by root L1 is equal to 25 P2 divided by root L2. Okay, so this implies 2 P1 divided by P2 is root L1 divided by L2. Let us square. 4 P1 square divided by P2 square is L1 upon L2. Okay, so L2 is equal to P2 square divided by 4 P1 square L1. Okay, and now I have the condition that L1 plus L2 is equal to L0. So what is L1? So L1 is, what do I say? Yeah, L1 I can write as it is. L2 is P2 square divided by 4 P1 square L1 equals to L0. So L1 is equal to L0 upon 1 plus P2 square by 4 P1 square. Okay. And L2 is equal to P2 square by 4 P1 square L1. And what is L1? L0 1 plus P2 square divided by 4 P1 square. So L2 will come out to be this, if we take LCM, so it will be P2 square and 4 P1 square L0 divided by 4 P1 square plus P2 square, because this 4 P1 square and this 4 P1 square will go. See, the moral of the story is that I have got values of these optimal values L1 star and L2 star. So these are the values of labor at which I am going to get my maximum output. Also, since L0 is also a variable here, so del L by del naught should also be equal to 0. And so what is my del L by del L naught, by the way? So my del L by del L naught is mm, uh, lambda, because it is minus lambda into minus 1. So that is lambda. So that is my del L by del L naught. So basically, then we have to write the value function. Okay. So eventually, what is my value function? My value function was, so let me just, so what is my value function? My value function was this 100 P1 root L1 plus 50 P2 root L2. This is my value function. And now this I'll have to substitute these values of L1 and L2 which I have obtained. Okay. So basically my value function will be 100 P1 L1 star plus 50 P2 L2 star. So just substitute the value of L1 star and L2 star. That is your value function. Okay. All right. So now what are they asking? They want you to find del y star by del P1, del y star by del P2 and del y star by del L naught using envelope theorem. So what is envelope theorem? So let's have some space over here first. And because if we start calculating the value function in terms of L1 and L2 star and then find out the derivative with respect to P1, we are going to get into a lot of derivatives which is not required. Okay. So basically, as per envelope theorem, so as per envelope theorem, what happens that your del y star by del P1 star, okay, uh, and your del y star by del P2 star and your del y star by del L naught, okay, they are nothing but they are equal to del L by del P1 star. This is equal to del L by del P2 star, and this is equal to del L by del uh, L naught. Okay, so you don't need to differentiate y star. You only need to differentiate L and L with respect to P1 star, P2 star, and L naught. If you want to get your what do I say? If you want to get your these three results using envelope theorem, so just use your Lagrange function as it was written. So what was your Lagrange function? Once again, so your Lagrange function was written as P1, so P1 and 100 P1 root L1, and then it was 50 P2 root L2 minus lambda times L1 plus L2 minus L naught. This was your Lagrange function, and we calculated L1 star and L2 star in terms of P1 and P2. So it is very easy to calculate now del L by del P1 star uh, and del L by del P2 and del L by del L naught. We already know that del L by del L naught is nothing but lambda. So using the envelope theorem, now it is easily, it will be very easy to calculate y star, the derivative of y star. Okay.